Hey guys, it's your boy Noah, back out here with another math video. But you know what we're covering today? We're covering conditional probability. So you may be asking, what is conditional probability and why should I care? Well, I'm not sure about the latter part, but I can tell you how to do it. Wait. What is probability? I need to go over that before I can even know about conditional probability. Just tell me. Alright. So, I guess I'll go over what is probability. Well, probability is the calculation of the chance that a certain event will occur in a random experiment, such as the probability of landing a coin 3 times in a row in tails. You can find the probability by putting the number of outcomes that the event could happen over the number of events in the sample size. So in my example about the coins hitting 3 times in a row tails, you would have to put the number of outcomes that this could happen, which is 1, and you put that over the number of possible outcomes, which is 8. So you could put the probability as 1 over 8, meaning that of 8 possible combinations, only one of them can be 3 tails in a row. Okay, Mr. Noah, we finally got probability. Now tell me about this conditional probability. Alright, well, back to the main question, what is conditional probability? Well, conditional probability only occurs when we have some knowledge about the outcome of an experiment. You use this when you want to find the chance that something will occur given that another event occurs. This comes in 2 forms: when the events are connected, meaning that the outcome of one event will directly impact that of another event, or independent, when each event has no impact on each other. Well, first off, let's go over the conditional probability of those events that are connected. For this, you'll need to use this equation. Wait, that looks really complicated. It has these weird U thingies, like upside down U's and squiggly lines. Well, I'll explain it to you. So pretty much, A stands for event A, B stands for event B. So the equation basically says the probability of A and B is equal to the probability of both event A and B happening divided by the probability of the given happening, which is B. So, how do I solve questions with conditional probability? Well, one of the easiest I can give you comes from a dice roll. You want to get a 5. Normally this will be a 1 in 6 probability, but in this case there's somehow a 100% chance that the roll will be an odd number. This brings your sample size from 6 to 3 possible outcomes. Therefore, the probability of rolling a 5 with a fair dice, given that you roll an odd number, is 1 over 3. Well, how did you do that? Well, we can apply it to this equation. Let me explain it to you. The probability of rolling a 5 when you're guaranteed either an odd number with a fair dice is equal to the probability of both, which is 1 desired outcome out of 3 possible. So 1 over 3 divided by the probability of the given, which is 3 outcomes. So 3 over 1, and then you put those over each other, which becomes 1 over 3. Hence, you have around a 33.333333% chance of getting a 5. I mentioned conditional probabilities with events that are independent of one another. Well, when an event is statistically independent, this means the effect of one event does not directly impact the results of other events. The results for this is pretty simple, which is just this. To put it simply, it's a probability of both event A and B is equal to the probability of A times the probability of B. So, you want an example of this weird independent correlational probability? Well, I have one right here. It's a pretty easy one, so you guys can follow along. So, Holly has a 70% chance of winning her first race and a 60% chance of winning her second race. What is the probability of winning the first race and losing the second race? You would plug this in to the equation by multiplying the probability of winning the first race, which is 0.70, by the chance of losing the second race. And since this is losing, I would have to subtract 0.60 from 1. So this comes out as 0.70 times 0.40, which is 0.28. So Holly has a 28% chance of both winning her first race and losing her second. As you could have noticed, that winning the first race doesn't exactly affect her chances of winning her second race, which is why this is independent. They have no correlation with each other. We're just trying to find the probability of finding both. Well, the thing to know about conditional probabilities is that a couple of the questions can get pretty complicated and can ask you for the probability of an event happening that multiple events are fulfilled. So this is when you might use a tree diagram. You can use the tree diagram to solve questions by giving you an easier way of understanding and solving these questions without plugging each and every one of the probabilities into the equation and adding them all up, which can get really tedious and time consuming. So you may be wondering, what in the world is a tree diagram? Well, I'll just give you an example of one. So there's a coin that is biased so that 75% of the time it lands on heads and 25% of the time it would land on tails. Given that you flip the coin 3 times, what is the probability of getting 3 tails in a row? You basically just create a chart for each possibility, and for each possibility branching out for each one of those probabilities. So you start out with the coin, and then 0.75% chance of getting heads, 0.25% chance of getting T. You do another layer of that, another one, until you have all of them. So like all of the different possibilities. So all in all, once you find the all of the possibilities, you can narrow down the one that you need, which is on the very bottom, which is tails, tails, tails. So the probability of getting 3 tails in a row is 0.25 times 0.25 times 0.25, which is a 0.0156 chance. So you would have a 1.56% chance of getting 3 tails in a row in this rigged coin flip. And that's all. Thank you for taking my little mini lesson. I know the questions were easy, but if you guys want a bit more of a challenge, you guys can just go down there into my weird slideshow, and I have an assessment there. I have a couple questions, I have the answers to them, solutions, and a couple of things that you may have gotten wrong in them. So give those a check out. I don't think that's how you say it, and peace.